In 1950, mathematician Alan Turing proposed a pragmatic way to evaluate a machine. He argued that if a computer's text responses were entirely indistinguishable from a human's, we should grant that the machine possesses intelligence. Over the following decades, engineers built systems capable of mimicking human cognitive tasks within strictly rules-based environments, eventually defeating world champions at games like chess. This capability quickly expanded from mathematical calculation into language. Machines learned to parse complex, nuanced questions, retrieve relevant data, and output correct answers in natural language. This trajectory fueled the rise of strong AI, the philosophical claim that a properly programmed computer is, in a literal sense, a mind. Strong AI relies on functionalism, a theory holding that mental states are defined entirely by their causal roles. If a system receives an input, processes it, and generates the exact observable output a human would, the system possesses understanding. Picture a heavy door with a mail slot. You write a question in fluent Chinese on a piece of paper and push it through. A minute later, a perfectly articulated, contextually accurate Chinese response slides back out. Based on the Turing standard, that perfect external behavioral fluency forces the observer standing outside to assume there is a conscious, comprehending entity operating on the other side. In 1980, philosopher John Searle published a thought experiment designed to dismantle that assumption. Searle drew on the historical precedent of human computers, workers employed during World War II to execute mechanical calculations. They processed long strings of data by following strict rules, requiring absolutely no understanding of the final project to complete their task successfully. Searle places himself inside the theoretical room. He speaks only English and knows absolutely no Chinese. The room contains boxes of Chinese symbols and an English rulebook that dictates exactly how to pair one set of symbols with another. When the paper containing the Chinese question slides through the slot, Searle picks it up. To him, the writing is an unintelligible series of squiggles. He consults the English rulebook. The rules instruct him to identify the symbols purely by their physical shapes. He matches the curves and lines of the input to the corresponding geometric shapes in the ledger, completely ignoring any linguistic meaning. Following the instructions, he retrieves a new sequence of Chinese symbols from the filing cabinets, copies them onto a blank piece of paper, and slides it back out the slot. To the native Chinese speakers outside, the room has just answered a complex question about a restaurant. Inside, Searle has total ignorance of the contents. He does not even know the Chinese word for hamburger. By showing that a blind mechanical process can generate perfect behavioral output without any internal comprehension, Searle invalidates the central premise of the Turing test. The mechanical reality of the Chinese room rests on a strict dichotomy, the difference between syntax and semantics. Syntax is formal. It is the physical manipulation of symbols based entirely on a predefined set of rules, exactly like matching the geometric shape of one squiggle to another. Semantics is the possession of mental contents. It requires an agent to attach actual, cognitive meaning to those symbols. This leads to Searle's central premise. The formal manipulation of symbols is insufficient to generate semantic understanding. No matter how complex the rulebook becomes, matching shapes never produces meaning. The manual ledger in the thought experiment operates exactly like algorithmic code executing inside a modern central processing unit. The CPU shuffles binary digits according to syntactic rules, without ever knowing what the data represents. The error of strong AI lies in conflating the simulation of a process with the duplication of that process. A computer simulation of digestion, no matter how detailed, cannot metabolize a piece of food. A computer simulation of a rainstorm does not leave the hardware wet. Simulating the external markers of language processing fails to duplicate the specific causal biological properties required to generate a conscious mind. Critics deploy the systems reply. They concede the operator alone doesn't understand, but argue understanding emerges from the system as a whole. The room itself understands. Searle rebuts this by internalizing the system. The operator memorizes the rulebook and database, effectively becoming the entire room. The operator leaves the room, walks outside, and converses with native speakers. He calculates the geometric rules and vocalizes the corresponding Chinese sounds entirely in his head. Despite internalizing every component of the system, The operator still has no idea what the Chinese sounds mean. The syntax-semantics gap remains. Another major counterargument is the robot reply. This suggests that a computer trapped in an isolated room lacks understanding because it lacks context. If you put the computer in a physical robot body with sensors and cameras, it could ground the symbols in real-world interactions. Searle addresses this by adding a video feed to the Chinese room. A stream of binary digits representing the digitized output of a camera is passed through. The operator consults a new set of rules to process the numerals. To the operator, the camera feed is just more meaningless syntactic input. Adding physical sensors or internalizing databases proves that accumulating more syntactic rules never bridges the gap into semantic understanding. To scale this argument to modern artificial intelligence, we have to examine the philosophical concept of intentionality. Intentionality is the inherent aboutness or directedness of a mental state. Biological agents possess original intentionality. When a human thinks about a restaurant, the thought is intrinsically directed at a real-world concept, backed by subjective, conscious understanding. Derived intentionality exists only because an external human observer projects meaning onto a symbol. The words printed in a book only mean something because a reader interprets them. A modern CPU does not interpret data, it merely undergoes physical state transitions. It receives electrical voltages and shuffles them according to its programming. A microchip switching voltages is a strictly physical reality. Reading and understanding is a cognitive act. If computation is merely a human projection, then real understanding must come from a different source. Searle points to the physical reality of the brain. Just as a stomach produces digestion through chemical interactions, the brain produces consciousness through specific neurobiological processes. This is biological naturalism, the assertion that minds are a biological feature of the brain's unique causal powers, powers that cannot be replicated by the execution of a program. Computation itself is observer-relative. Humans arbitrarily decide to assign the value of 0 or 1 to the electrical states of a machine, and humans assign meaning to the output. The machine remains completely blind to its own processing. This applies directly to large language models. Crawling vast databases of human text and scaling up the number of transistors allows the machine to predict the syntactic sequence of words with incredible precision, but it does not spark original intentionality. The perception that the machine understands what it is saying is derived intentionality. It is an illusion created entirely by the user projecting meaning onto a mathematically generated string of text. The logical derivation of the Chinese room leaves us with a stark conclusion. Programs are purely formal. Human minds have actual mental contents. Syntax by itself is neither constitutive of nor sufficient for semantic content. Therefore, programs, regardless of their complexity, speed, or behavioral perfection, are not constitutive of minds. The illusion breaks the moment the mechanical processing behind the boundary door abruptly halts. Beneath the veneer of perfect artificial conversation, there is no comprehension, no consciousness, and no mind. There is only an absolute, unthinking void.